Okay. So section 2.3 is where we are learning how to write linear equations. So in the section 2.2, we learned more about calculating our slope and our y-intercept using linear equations, graphing linear equations, and how we do that. In this case, we're going to use points and slope to actually write the linear equation. Really bad. All right. So I'm just going to kind of read some of this on page 69 is where this section starts. And it asks, what do sports, maps, the stock market, social issues, and hurricanes all have in common? They all have data that we model by using linear functions. So these functions allow people to make predictions beyond known data. For example, because X is your independent variable and Y is dependent on X, then you can make predictions that if Y equals whatever, the storm moves southeast at some rate, then Y is going to tell you like at what time, at this miles per hour or something. And then Y will tell you what time the storm will get to landfall, maybe where it gets to population density. And so you can determine at what point that area is going to be in danger, right? So that's the kind of thing we're talking about with using the X and Y intercept. And that's what it means by dependent. So dependent on the speed of the hurricane and the direction of the hurricane, we will then know when it will make landfall in a certain and where it will land. So that's what they mean by dependent and independent. And so that's what we use these. So we write linear equations where if you adjust X, so if you adjust the speed or you adjust the direction, you can then determine the time or you can determine the place. And so they make predictions based on that. All right. So when the slope, which is M, and the y-intercept, which is b, so, slope is the variable m. Y-intercept is the location where x is 0 and y is some value b. You can use those to write the lines equation. So when the slope and the y-intercept can be easily derived from a graph, you can immediately write the lines equation using the slope-intercept form of the linear equation. So slope-intercept form, which we talked about last section, is y equals mx plus b. Again, where m is your slope, so that's your rate of change, up or down, right? So if we're going uphill, we've got a positive slope. If we go downhill, we've got a negative slope. And then y-intercept is the b. So at the end of that form, that linear equation, you've got the value of y when it intercepts the y-axis. Excuse me. So those on the video, I'm not going to try to draw it. It'll take me too long. But on page 69, we've got that small graph where all they have given you is a graph. But you can tell from this graph that we have a y-intercept. That's usually the easiest find. Look at your y-axis. At what value of y does that graph intercept the y-axis? And we go 1, 2, 3, up 3. So we know that b is equal to 3 in this graph. And then the slope, we can pick 2 points that are pretty easy to see. I'm going to use the one, I'll use the y-intercept. So that is 0, 3. And then if you look down and left, then at x, negative 1, 2, 3. So where x is negative 3, y is 1. I'll pick that one. X. gonna work. So you can plug that in, but you get your slope, or they've told us in the paragraph that you have a slope of 2/3. And we'll see that. So y2, so that's 1 minus 3 over -3 minus 0. So this 1 minus 3 is -2 over -3, and that's where we get our 2/3. That's our rise over run. So m equals 2/3. And then you just pick any point x or y, because this graph has arrows pointing to infinity, left and right, up and down. And so you just pick x to match any value of x and y for any value of y. And you've got y equals your slope 2/3 times the x value at that y plus, 3. And there's our linear function based on the graph that we see right there in the middle of page 69. All right, so let's look at it where we're not having to look at a graph. We're actually just given the information. We call this, we're going to use what's called the point slope form, which makes sense because it's where you're given a point and you're given the slope or the rate of change, and you're asked to write a linear function. So this is example 1. So they want us to write a linear function where the line passes through point 2, 1. So x is 2 and y is 1. And it has a point. And then it has a slope of 2/3. So first off, we know our slope is positive. So if we did have to graph this, you would want to see a graph that's going uphill because you've got a positive slope, just for reference. So if you graph something going downhill or crooked or sideways, then you know you've got a problem. All right, so we start with our slope form. Y equals mx plus b. And so we use this first to calculate our y-intercept, because we have a point and it gives us an x and it gives us a y. So for the y, we're going to use number 1, and then m is our slope, which is 2/3. X is 2, and b is our unknown. So y stays 1. This is just 2 times 2. So it changes our, this is 2 over 1. So when you multiply that, it's just 2 times 2 in the numerator, 3 times 1 in the denominator. So it's 4/3 plus b. So I'm going to rewrite 1 as 3/3 so that I have a similar denominator. Bless you. And then subtract 4/3 from both. So all I'm looking at is my numerator. When I subtract, the denominator stays 3. Also, know it's going to be negative. So 3 minus 4 is -1. So our slope, my y-intercept is -1/3. So when it intersects the y-axis on my graph, it's going to happen, if this is 1, 2, then it's going to happen somewhere around right here, right? Because it's negative, so it's under the x-axis, but it's not quite at 1, so it's at 1/3, about right there. Excuse me. So now that I have that, I can, well, they cleared it of equations or of fractions. I'm not. But anyway, that gives us our final linear function, because they gave us slope and they gave us, and we just calculated our y-intercept. So again, I'm going to go back to my slope form. Y equals, slope, which is 2/3 x. And then I just calculated my y-intercept, which is -1/3. And there is my final linear equation. for the graph that goes through 0.21 with a slope of 2/3. All right, so this is the third form, yes, sloped intercept form. So the third form of a linear equation is called the point slope form, which I want to give you that. They show the proof of it, like where it comes from. It all comes from the slope form, or excuse me, what am I trying to say? The slope, the rise over run formula. This is point slope form. Again, which makes sense because similar to what we just did with our first example, where we calculated our y-intercept so that we could write the linear equation. You're given a point that the graph goes through, and then you're given the slope or the rate of change. But the equation for that is y minus y1 equals m times x minus x1. So just have that somewhere nice and neat, or obvious to find. Put it on note cards if you use note cards. But I want to show you where that comes from. So we start with the slope formula, which is slope equals the difference in 2 points, y2 minus y1, x2 minus x1. Because again, it's rate of change. So it's the difference, the ratio of the difference in y and the difference of x. But we need to replace 0.2 with a generic point. Everybody got that point slope form? I'll come back to it. So in this case, we have, P 0.1 is our y, x1 and y1. But instead of 0.2, we just want to have, for every point that exists on the line, it has an x and a y, an ordered pair. And we're placing 0.2 with that. So those will stay, even at the end, those are our variables x and y. And they will stay x and y because you're only given 1 point, which you'll see in the next example. And so once you replace that, it ends up being slope equals just y minus y1 over x minus x1. And then you use your symmetrical property of equality, and we're going to multiply, get rid of that denominator. We don't want denominators, no fractions. We can help it. And this cancels out. And so then we end up with the point slope formula, which I'm going to write backwards, but it's the same thing. Y minus y1 equals slope times x minus x1, with y1 and x1 being the given point that you're given in the problem. So for those of you that need to know where these formulas come from, that's where it comes from. Now let me show you how to actually use it, which I think will help make it make a little bit more sense. So let's go back to our another version of our example 1. So example 2, we have the same information. They want us to write standard form equations. So this is your f of x where, oh, that's right, they want it in standard form. They don't care. Okay, they don't care that it's in slope intercept form. So you have a line. So a line passes through 0.21, where x is 2 and y is 1. And it has a slope of 2/3. So same data, but let's use our point slope form. So with point slope form, we have y minus y1 equals m times x minus x1. So the point that they just gave us, so that is our point 1. So that's your y1 and your x1. Because remember, in standard form as well as in our slope-intercept form, we always have an x and a y. You know, it's y equals something x plus or minus that y-intercept. So it's okay that you're going to end up with 2 variables. These guys are going to stay variables the whole time. So that means that this is x1 and this is y1. And they've given us our slope. Slope is m. So plug in the values that you know. And y is our unknown, and will stay that way. So y equals, or y minus 1 equals slope 2/3 times x minus 2. It's what? So this we can now solve. All right, but what I'm going to do to solve it is I'm going to get rid of that 2/3. So what do I have to multiply everything by to get rid of my fraction? 3. So if I multiply this times 3, I don't have, the 2/3 is already being multiplied times the x minus 2. So by multiplying 3 times 2/3, I'm already impacting, I'm already multiplying it times x. You don't multiply it by both of those because they're being multiplied. The only time every term that you multiply is the ones being separated by addition or subtraction. This one is not. This is multiplication. So then we do multiply the y times 3 and that 1 times 3. Sorry, it's kind of all over the place. So these cancel out, gets rid of my fraction, which was the point. So this side ends up being 2 times x minus 2. And then this is 3y minus 3. So now what do? We distribute. And we distribute into every term. Now this is where that multiply times 3 it interacts with the x minus 2, the expression inside the parentheses. So 3y minus 3 equals 2x minus 4. Now I'm going to move all of my, let's get rid of this 3 first. Combine like terms. I only have that 1, but I'm also going to move that 2x to the other side. 3y, so I have all my variable terms on one side and all my constant on the other. 2x, negative this minus 1. Now I'm going to move my 2x over by subtracting it. I know. All right, so 3y minus 2x. I can't interact the coefficients at all. These are 2 totally different terms. And equals negative 1. That is as simple as we can get. And that is standard form. Which I hate. I would always want to put that in y-intercept form. Why wouldn't we? Can we just do it? Let's do it. So y-intercept form is just y equals mx plus b. So I'm going to isolate. So when you put it in slope-intercept form, then you are just isolating y. This is that whole linear equation part of chapter 1 that made everybody cry, but we use it all the time. So the more you use it, the more it'll make sense. Now it makes sense because we know we're trying to find our y-intercept. So 3y, and hold on, here we go. 3y minus 2x equals negative 1. Yeah, I would assume so. I'm gonna see if this works. Okay, so we add 2x to both sides. I'm gonna do it down here, 2x. All right, so 3, and I'm gonna use my symmetrical property to move things around so they're in the right place. 2x minus y. Divide everything by 3. Y equals 2/3 x minus 1/3, which is the same formula that we had from last time. Which makes sense. Yeah. Because if you look at example 1, where we did this using our slope-intercept form, we got the same thing, 2/3 x minus 1/3. We used the same point with the same slope, and we got the same linear equation. Oh, this is the, and I keep calling it both, it's slope-intercept. Well, slope-intercept form because it gives you the slope and the y-intercept. I will also sometimes call it the y-intercept form. All right, let's look at example 3. So for example 3, they're not giving us our slope, but they are giving us 2 points. So again, if you have 2 out of 3 things, you can find that third. Right? Because we can use 2 points on a graph to figure out what the slope of that graph is. So this is just kind of a repeat of using that. And then we're going to use it to write the slope-intercept form of the equation. So for example 3, I have a line that passes through -4, 3 and 2, 6. All right. So point 1, I'm going to have as -4, 3. Point 2 will be 2 and 6. So this is my x1, y1, x2, y2. My slope is rise over run, which is y2 minus y1 over x2 minus x1. Y2 is 6 minus y1, which is 3. X2 is 2 minus x1, which is -4. So I have a 6 minus 3, which is 3. And then I have 2, this is 2 plus 4, right? Because subtracting a negative is addition. And 3 over 6, which simplifies to 1/2. So now I have my slope. So now what do I do? I've got to actually write the form. Does it matter which point I pick? No, the equation is going to be the same. But I'm going to pick the one with the 2 and the 6 because it's easier. So we have to use it to find our, yeah, you're going to get the same answer either way. So we use it to find our y-intercept because we have to have our y-intercept and our slope. Our y-intercept and our slope are our 2 known values in the linear equation. The x and the y are unknown because it's every infinite ordered pair on that graph. Those are the x and y's. That's what an equation is representing. It's representing every single point, and the equation will work for every single point. It will, if you think of an x that falls on that graph, it will tell you can calculate the y. All right, so we've got to find, so the first one we calculated our slope. The second, we need to calculate our y-intercept. So pick a point. I'm going to pick point 2. Y equals mx plus b. So I'm going to pick from these 2 points my y and my x. So y is 6. Slope I just calculated is 1/2. X is 2. And b is my unknown. So what is 1/2 of 2? What is half? Think, what is 1/2 of 2? It's just 1. So we subtract 1 from both, and this graph is going to intersect the y-axis at +5. So this is step 2. Calculate your y-intercept. This is step 1, where we calculate our slope. Step 3 is we put it all together. Y equals mx plus b. So that means for every y, the slope of 1/2, so half of the value of x plus the y-intercept gives us the value of y at that point. So there's our final slope-intercept form. It will specify standard form or slope-intercept form. So at the bottom of page 70, they are reminding you about parallel lines versus perpendicular lines. So parallel lines have the same slope. Oh, I remember this tripping y'all up so bad in algebra. Parallel lines have the same slope, and the slopes of perpendicular lines are negative reciprocals of each other. Negative reciprocals. Terrifyingly familiar. All right, so look at those graphs at the bottom. We have parallel lines for two separate. Now the equations are different. You've got one over here. I'm not going to do the graph, but just so you can kind of see something similar. Or I'm not going to do the Cartesian plane. I'm just going to kind of draw the graphs. So we had y, this one, y equals 3/2 x minus 3, which mine probably does not. This one is y equals 3/2 x plus 3. So it just means, you know, if you've got your Cartesian plane somewhere, which nope, I'm not going to do it. That remember this, so that means that this line is going to intersect the y-axis at a +3, so 3.3 units above the x-axis, and then the blue one, or maybe mine's purple, is going to intersect the y-axis 3 points below. And you can see that. You see that. You see, oh no, sorry, that's supposed to be a 2, isn't it? Why am I like this? I swear I need a nap after lunch. 3, so it intersects the y-axis at +2. Y'all see the difference in the equations on that graph? But their slopes are the same. You know, so if this is line 1 and this is line 2, then the slope of line 1 is going to equal the slope of line 2. Their rate of change is identical. They're both, you can see that, 1.5 or 3/2. Okay, perpendicular lines, you also, so if we have one going like this and mine is not, well, I can try. That's right, perpendicular lines make perfect right angles. So like we'll know that this is perpendicular. And it makes sense that they would be opposites because this one is negative and this one is positive. One's going, huh? Right, uphill and downhill. Uphill is positive, downhill is negative. Even though in my mind, having to walk uphill is much more of a negative experience than having to walk downhill. Right. Yeah. So the thing that you have to understand about the slope here, Mine are not nearly to scale as theirs are. Theirs is, but the slope of this, the equation for this one going downhill, y, is negative 1/3 x plus 2. And the other is y equals 3x plus 1. Oh, excuse me, minus 1. And so then if you compare the slopes, we know that the reciprocal of 3 is 1/3. And the opposite of 3, the opposite of a positive 3 is a negative 3. So that's why the slope, we'll keep the, yeah, keep it this one. So the slope of the first line, if this is line 1, is the opposite reciprocal of line 2. Whoopsie. Am I still sharing? I don't know. Let's try that. Must have unshared it. Sorry. For line 2. Is it? Oh yeah, we're good. Okay. We'll do plenty of practice. So let's talk about this. So if the slope of 1 is, I don't know why I love this fraction, but I do, is negative 4/9. What is the slope of a perpendicular graph to negative 4/9? Yep. That's not equal, sorry. Positive 9/4. So line, if this is the slope of line 1, then what is the slope of a perpendicular, or what is the slope perpendicular to line? It's the opposite reciprocal. It's the opposite reciprocal. So if you know 1 and they say, write the equation or give me the slope-intercept form or the linear equation for a line perpendicular to this line, then you know the slope of it is going to be the opposite sign and the reciprocal. Okay, we got that? That's all you got to do. Opposite, reciprocal. When we have perpendicular lines. Okay, let's move on to example 4. In this case, they have given you a point and then they have given you a equation. This is a standard form equation. Let's see here. Sure I'm not missing something. I don't think so. All right, write the standard. So example 4. Where did I leave off? Just randomly change colors. Okay, so write the standard form equation of a line passing through point -2, 3 and parallel, here we go, PAR, parallel to x plus 2y equals 8. All right, so they're parallel, which means what is going to be different? So your y-intercept is going to be different, right? It's going to move left or right, up or down, but it's parallel. So what is the same? Your slope. Your slope is whatever that thing. Yeah, whatever, your slope stays the same. The rate of change is the same because they're parallel. They're changing at the exact same rate, but your y-intercept is going to be different. So what you Oh, let me see here. So you've got to take what they've given you and determine what the slope is. That gives you the slope. Then you use your point, plug it into your linear equation to calculate what your y-intercept is. Bless you. Okay, so the slope of our, I'm confused about this whole mg thing. I'm just going to use my point. Because they gave us a point, slope. All right. We have x plus 2y equals 8. And so we subtract x, 2y equals, I'm going to keep it in slope intercept form. So negative x plus 8 and divide by 2. And that is where I get my slope. Y equals negative 1/2 x plus 8. So is everybody good on how I got from negative x divided by 2 to negative 1/2 times x? Y'all see that that's the same thing. Because what's the coefficient of a variable? 1, when they don't give you 1. Right, in this case, it's negative 1. So I'm just pulling out my x because that's just negative 1 times x divided by 2, which is negative 1/2 of x. Okay, so that gives me my slope, and I know what my slope is. So now I have my slope and I have 1 point, so I can use my point slope form. So writing for any generic y minus y1, so this is step 1, slope. Now I got to figure out my, I'm on the wrong one, my final equation. So y minus y1 equals slope times x minus x1. And then I plug in everything except for the y and the x. So this is y minus y1, which is 3, equals the slope, which is negative 1/2 times x minus x1, which was negative 2. So that's x plus 2. All right. And then I'm going to go ahead and distribute the 1/2. 1/2 is so easy. Y minus 3 equals negative 1/2 x, which I already knew because the slope is the same. And then negative 1/2 times 2. What is half of 2? 1. And what is a negative times a positive? So negative 1. All right. So yeah, well, I'm going to add 3 to both sides. Oh, they must have. They do. Did they get rid of it? Oh, they did get rid of their fraction. Y, let's see. So y plus 1/2 x. I'm going to move that 1/2 x as well. Do it either way. And then equals 2. Yeah, that's the same thing. X plus 2y equals 4 is the same as 1/2 x plus y equals 2. I'm just keeping my fraction. I think that might be all that we have time for. So I'm going to go ahead and leave it at that. So tomorrow we will finish this section. Right, then I'll give you guys, we will probably be able to start the homework assignment tomorrow during class, and then I'll have you finish it for homework. And then we will go over the homework on Friday, do our quiz review on Monday, and take the quiz on Tuesday. Yes. Is next week a normal week? Are we having to go anywhere? Anybody going anywhere Monday and Tuesday?
Out early Wednesday.
That's right, because I want to have it done before I leave for teachers conference. Otherwise, we're gonna have like 5 days off and you're gonna forget everything. Yeah.